Welcome to Lesson 25, the Stage 3 Capstone. Over the last 7 lessons, you've built up the core pieces of IP addressing, subnetting, VLSM, CIDR, IPv6, SLAC, NAT, and the dual-stack realities of modern networks. Now it's time to bring all of that together into a single, coherent mental model, the kind a senior engineer reaches for when designing a network from scratch. So here's the path for the next few minutes. First, we'll stitch all 7 Stage 3 lessons into one unified mental model, the framework you'll actually reach for at the whiteboard. Then, we'll design a complete IPv4 and IPv6 plan from a true greenfield, walk through a realistic design ticket the way a senior engineer would, and finish with a quick self-check and a look ahead at Stage 4. Let's take a moment to lay out the 7 lessons we're consolidating. Lesson 18 grounded us in IPv4, 32 bits, place values, the network host split. 19 and 20 built our subnetting muscle, from the magic number trick into variable length subnet masks. 21 zoomed out to CDR and supernetting, 22 covered private space and NAT, and then 23 and 24 carried us into IPv6 and the realities of dual stack transition. 7 beats, one mental model. Now watch how those 7 beats collapse into a single design. The ISP hands us a public IPv4 address and a 48 of IPv6, both terminating at the edge router. Internally, we carve RFC 1918 space into 4 24s, users, servers, voice, and guest, each paired with its own chart64 of IPv6 from our 48. Those 4 24s summarize cleanly into 10.10.022 for routing. The edge runs dual stack outward and NATs only the IPv4 side. Every Stage 3 concept, one diagram. That single diagram only works because 5 principles sit underneath it. Right size every subnet with VLSM. Never burn a 16 on 10 hosts. Allocate the largest blocks first, descending by host count, so you don't fragment your space. Summarize at every aggregation point. A branch advertises 1 22, not 4 24s. Plan IPv6 from day 1, take a 48, hand out 64s, and mirror your VLAN IDs into the subnet ID so the 2 stacks read the same. And document all of it, an IPAM tool or even a spreadsheet, but never lose that map. So let's put those principles to work on something real. Brief 3017. Design a dual stack addressing plan for a new Budapest branch, 200 users with the ISP handing you a 10.20.022 on the v4 side and a 2001 dBi cafe 48 on the v6 side. You've got 5 distinct host groups, PCs, phones, servers, IoT, and point-to-point uplinks, and you need 50% headroom over 3 years. 4 questions to answer. Does the 22 actually fit? What order do you allocate? How do you tie VLAN IDs into the IPv6 subnet ID? And what does the final table look like? Let's work it. Step 1 is the sanity check. A 22 gives you 10 to 24 addresses. Your base need is 200 hosts. 300 with the 50% growth buffer, plus 12 more for the 6 point-to-point links. That's roughly 312, well under 1024, so the block fits with real headroom. Step 2, always allocate largest to smallest. Users take a 24, phones a 25, servers a 26, IoT a 27, and each point-to-point link gets its own 30. Every group lands with growth room baked in. Now layer IPv6 on top and notice the elegant trick. The VLAN ID becomes the IPv6 subnet ID. VLAN 10 maps to Cafe 10, VLAN 20 to Cafe 20. Servers on 30 land in Cafe 30. Instant mental mapping, no lookup table required. The point-to-point links get Cafe F1 and F2, marking them as infrastructure rather than user space. Every group fits. Growth is covered, and the 22 still has room from to onward for whatever comes next. That's how a senior designs. Deliberate patterns, not arbitrary numbers. With that design in mind, it's time for an honest gut check. 10 questions, 30 seconds each. If any one of them makes you hesitate, the lesson number on the right tells you exactly where to go back. These aren't trivia. They're the reflexes a senior engineer leans on every day, from binary conversion and magic numbers to summarization, RFC 1918, PAT, IPv6 compression, SLAAC, and a full mixed prefix design. Work through them out loud and be ruthless with yourself. That's how the mental model locks in. And once those reflexes are in place, this is what you've actually earned. You can move between binary, decimal, and hex without breaking stride. Subnet any prefix in your head with the magic number. Carve out VLSM plans that waste nothing, and configure at and pat on real enterprise gear with confidence. On the IPv6 side, you can summarize cleanly for BGP and OSPF and deploy dual stack in production. That's not study-level knowledge anymore. That's a senior's toolkit. With that toolkit in hand, the natural next question is, where do those addresses actually go? That's stage 4, routing. Over 8 lessons, from L26 to L33, we'll move from how a single router makes a forwarding decision through static routes, distance vector with RIP and EIGRP, into OSPF in both single and multi-area designs, then up to BGP for inter-AS routing, and finally, redistribution and route maps before the capstone. In short, the moves that actually connect networks together. Before we step into routing, let's lock in the 5 mental models you carry forward. First, IP is binary. Decimal is just a convenience for humans. Second, the magic number trick subnets any prefix in seconds. Third, VLSM right sizes your subnets, and you always allocate the largest block first to avoid fragmentation. Fourth, SIDAR and supernetting summarize routes, and longest prefix match always decides the winner. And fifth, in 2026, dual stack is the default, a 48 from your ISP, a 64 per subnet. Internalize those and you're already thinking like a senior. And here's your cheat sheet. Pin this one. Everything from stage 3 distilled to a single page. 32-bit IPv4. The place values 128 down to 1. The magic number trick. 2 to the host bit minus 2 for usable addresses. VLM largest first. Supernetting by common prefix. Longest prefix match for routing decisions. The RFC 1918 private ranges. And NAT or PAT for translation. If any line here feels fuzzy, that's your cue to loop back before we open stage 4. And that closes stage 3. Next up, lesson 26, routing fundamentals, where stage 4 opens and we shift from how addresses are built to how a router actually chooses a path. Bring the cheat sheet with you, because every decision a router makes leans on what you just learned. I'll see you in the next lesson.